Okay, so why can we add up to 100? So the first thing we have to do, or 1,000 or 1,000,000. First we have to look at this series. 1 plus a half, plus a third, plus a fourth, plus a fifth, plus a sixth, plus a seventh, plus an eighth, plus going on forever. Yeah. And so all the series that has all the unit fractions.
I have an idea on how to solve this.
Okay, what is your idea?
Well, 1 plus 2 plus 3 plus 4 plus 5 all the way up is minus a 12, so this might be 1 over minus a 12.
Oh, interesting. It might be 1 over minus a 12. What would that be? What is 1 over minus
12?
Yeah. So you might be right. It might add up to minus 12. That's an interesting guess, because infinite series do have very strange properties.
Yeah.
But unfortunately, what we're saying is it's got in a finite amount of time. So we're never going to have an infinite number, so we won't get some of those strange results.
Yeah.
Yeah.
But I mean, it looks like if we stop it at points, you're going to get above 1, but not that much bigger.
Yeah, this is one of the amazing things. This is called the harmonic series. And it's all the inverses. And there's one interesting way to look at it by grouping the series in powers of 2. So I'm going to let this one be by itself. I'm going to let that one be by itself. Then I'm going to group those together, and then the next ones are going to be a 9th plus up to 1/16. I'm going to group those together.
Yeah.
Plus, and then I'm going to group 1/17 up to 1/32 together.
Yeah.
And then the next grouping would go up to 1/64, and then, so I'm curious to see if you guys can see what we can say about these groupings. 1 and a half are easy to say something about. What can we say about a third plus a fourth?
Well, it's 7/12.
Okay, well, we can say what it is.
Yeah.
All right, we can't quickly say what this is. So there's something kind of simpler than the exact value that we can say about it.
Well, we're grouping them at 1 over the powers of 2.
Yep, we're grouping them in groups of 1 over the powers of 2.
They don't seem to add up to 1.
Well, they don't add up to 1, that's for sure. They don't add up to 1. This, adds up to 7/12.
Yeah, or close to 1, I guess, either.
No, not necessarily close to 1. But those groupings do have an important property.
1.
What's something simple you can say about 7/12?
Well, it's close to a half.
It is close to a half. Let's be even more precise.
It's above a half plus a 12th.
It's above a half.
Yeah.
Okay. So this is above a half, greater than 1/2. A third plus a fourth is greater than 1/2. What about this? A fifth plus a
this
sixth.
is bigger than a half, because I know that 4/8 is a half, and these are all bigger than an eighth.
Ah! A fifth is bigger than an eighth. Why?
Because
Can you tell me why?
a fifth is bigger than an eighth because an eighth is 1 divided by 8, and a fifth is 1 divided by 5.
Okay, so why does that
dividing it into larger parts.
Spreading into larger parts. So this is also bigger than a half. We don't know what it, I mean, it wouldn't be that hard to figure out. We could probably figure out exactly what it adds up to. We know it's bigger than a half.
And the same would hold true for this.
Same would hold true for this. And that.
So you group them in ways that are all bigger than a half.
We can group it into pieces, and those sums in each piece are all bigger than a half.
So that means you could use these sums to add up to numbers? Maybe.
Well, yeah. So how many of these groupings would I need to have to get up to bigger than 100?
Like
at least 200.
Okay, I would need at least 200 of these groupings, and that would be, well, the first grouping is 2 to the 0, 2 to the 1, 2 squared, 2 cubed. This is the first, second, third, fourth grouping. So I need 200 groupings, so that once I get down to 1 over 2 to the 199th, which is a huge number, right? But I know I'm bigger than a half. That I know that that sum's bigger than 100.
Yep.
But then you'd have to, for huge numbers, you'd have to go even huger.
And they wouldn't be accurate because you have to use like the really tiny fractions to get up to the numbers you wanted.
Yeah, but at least I know, at least now, see, in the prior video, we didn't even know if you could get to 100. So we're not going to figure out, there's actually no way we're going to figure out how you sum up to 100 exactly.
Yeah.
But at least now we know we can get bigger than 100.
Yeah.
So we know it's at least like possible that you can get exactly to 100. Maybe, or at least we can sort of believe it's possible
Yeah.
to get to exactly 100. Because now we know we can get bigger than 100. How much would I have to do to get bigger than 1,000?
So at least 2,000.
At least 2,000 of these groups. So I'd have to go up to 1 over 2 to the 1,999.
Jeez.
Yeah, so I mean that's a absolutely gigantic number. But at least it does it. So this is actually a really neat argument that I can make these groups that all sum to bigger than a half, and then I get larger. So it's pretty cool.
You need like a supercomputer to compute like 1,000 even.
You might need a supercomputer to compute even 5. But maybe not. I don't know. But we're gonna play around with this a little bit now that we know we can get up to any number we want.
Okay.
We don't know how exactly to make it exactly equal, but at least we know we can get up that high.
Yeah.
Okay, so let's go to the computer.